Ladies and gentlemen, this isn't just a story about cars, and it's not just about a machine. This is the story of how an entire industry was challenged at its core. For over 100 years vehicles were built the same way, piece by piece, slow, complex and heavy. Then one question changed everything: what if the factory itself became the product? What if a single move could erase hundreds of parts, cut time in half, and redefine how the future is manufactured? What you're about to hear reveals the real reason behind one of the boldest manufacturing decisions ever made, and why it's quietly reshaping the future of mobility before most people even realize it. And the real reason Tesla developed the Giga Press goes far beyond making bigger metal parts or showing off manufacturing muscle. It comes from a fundamental belief that the future of sustainable transportation depends not only on better vehicles, but on radically rethinking how those vehicles are built. From the very beginning, Tesla has treated manufacturing itself as a core product, not a background process. The Giga Press is a direct result of that philosophy. And traditional car manufacturing relies on hundreds of individual stamped parts that are welded, bonded, and fastened together to form a vehicle's structure. This approach is complex, slow, and expensive. Every additional part increases weight tolerances, supply chain risk, and the chance of defects. Tesla questioned why a car body should be assembled like a puzzle when it could be formed more like a single optimized structure. The Giga Press was developed to challenge decades of accepted industry practices and replace them with a simpler, faster, and more efficient system. And at its core, the Giga Press enables large-scale single-piece aluminum castings that replace dozens, and in some cases hundreds, of separate components. This dramatically reduces part count, which immediately translates into fewer robots, fewer production steps, and less factory floor space. By simplifying the structure, Tesla can also improve dimensional accuracy, making vehicles more consistent and improving overall build quality. The result is a body that is lighter, stronger, and easier to produce at scale. And speed is another critical factor. To accelerate the world's transition to sustainable energy, vehicles must be produced in massive volumes without sacrificing quality or affordability. The Giga Press allows cycle times measured in minutes rather than hours. This enables factories to ramp production faster and respond more effectively to global demand. Instead of expanding factories endlessly, Tesla can produce more vehicles within the same footprint, increasing output while controlling costs. And cost reduction plays a major role, but not in isolation. Lower manufacturing costs make electric vehicles more accessible, which directly supports broader adoption. By consolidating parts into a single casting, Tesla reduces material waste, logistics complexity, and labor requirements. Fewer suppliers are needed, fewer shipments are required, and inventory management becomes simpler. These efficiencies compound across the entire production system, allowing resources to be redirected toward innovation, safety, and energy efficiency. And the Giga Press also unlocks new possibilities in vehicle design. Engineers are no longer constrained by the limitations of stamping and welding multiple parts together. Instead, structures can be optimized from the ground up for strength, crash performance, and integration with battery systems. This approach aligns perfectly with Tesla's structural battery architecture, where the vehicle body and battery pack work together as a single system. The Giga Press makes this level of integration practical and scalable. And sustainability is another driving force. Fewer parts and fewer processes mean lower energy consumption per vehicle produced. Advanced aluminum alloys can be recycled directly within the production loop, reducing waste and minimizing environmental impact. The Giga Press supports a closed-loop manufacturing system where efficiency and sustainability reinforce each other rather than compete. And perhaps most importantly, the Giga Press represents a mindset. It reflects a willingness to question assumptions that have gone unchallenged for decades. Instead of optimizing around existing tools, Tesla builds the tools needed to achieve its goals. This vertical integration allows rapid iteration, continuous improvement, and tighter control over quality and performance. And the development of the Giga Press is not about building cars the same way, just faster. It is about redefining what modern automotive manufacturing can be, creating a system that is simpler, stronger, more scalable, and more aligned with a sustainable future. And this manufacturing-first approach also creates a powerful feedback loop between engineering and production. When a single casting replaces an entire sub-assembly, changes that once required retooling dozens of parts can now be implemented in one place. This allows faster iteration cycles and quicker deployment of improvements across global factories. Instead of waiting years for a full model refresh, refinements can be introduced continuously, improving performance, safety, and manufacturability at the same time. And the Giga Press also reduces variability, which is one of the biggest hidden challenges in large-scale manufacturing. Traditional assemblies accumulate tolerances from each individual component, and those small variations can stack up into alignment issues, noise, vibration, or long-term durability problems. A single piece casting eliminates many of these tolerance stacks entirely. This leads to vehicles that feel more solid, quieter, and more consistent from one unit to the next, reinforcing a premium experience while maintaining mass-market scalability. And from a factory design perspective, the impact is transformative. Production lines become shorter, cleaner, and easier to automate. Fewer stations mean fewer failure points and simpler quality control. This makes it easier to replicate factories around the world, enabling rapid global expansion without reinventing the production process each time. The Giga Press becomes a foundational building block for factories designed around efficiency rather than legacy constraints. And there is also a strategic advantage in supply chain resilience. By consolidating many parts into a single casting produced in-house, dependence on a complex network of external suppliers is reduced. This helps protect production from disruptions, shortages, and logistical delays. Vertical integration allows tighter coordination between material science, casting technology, and vehicle engineering, ensuring that each evolution of the vehicle is supported by corresponding advances in manufacturing capability. And material innovation plays a critical role in making the Giga Press viable. Specialized aluminum alloys are engineered to flow correctly into massive molds, cool uniformly, and achieve the required strength and ductility for safety-critical structures. These alloys are designed not just for performance, but for recyclability, allowing scrap material to be reused directly in the casting process. This further reduces environmental impact while maintaining high material quality. And safety is another area where the Giga Press delivers advantages. Large castings can be engineered with optimized load paths that distribute crash forces more effectively. By designing these structures as a single unit, engineers gain greater control over how energy is absorbed and redirected during an impact. This leads to stronger occupant protection without unnecessary weight, aligning safety goals with efficiency and range improvements. And the decision to develop the Giga Press in-house rather than rely solely on existing industry equipment reflects a broader philosophy of first principles thinking. Instead of asking how cars have always been built, the question becomes how they should be built, if starting from scratch with modern tools, advanced materials, and software-driven optimization. The answer is a system that prioritizes simplicity, speed, and scalability at every level. And as production volumes increase, the benefits of this approach compound. Each additional vehicle produced benefits from the same reduced complexity and optimized processes, driving costs down further over time. This scalability is essential for making electric vehicles accessible to a wider audience, which directly supports the mission of reducing reliance on fossil fuels. And the Giga Press is also a signal to the broader manufacturing industry that innovation does not have to be incremental. Large, bold changes can deliver outsized gains when guided by clear objectives and a willingness to rethink fundamentals. It demonstrates that manufacturing can be a source of competitive advantage rather than a fixed cost to be managed. And by integrating design, materials, and production into a unified system, the Giga Press helps bridge the gap between ambition and execution. It enables rapid growth without sacrificing quality, supports sustainability without compromising performance, and transforms factories into highly efficient machines built for the future of mobility. And this integrated approach also reshapes how software and hardware interact within the manufacturing process itself. Advanced simulation tools are used to model the flow of molten aluminum, cooling behavior, and structural stress long before a physical part is produced. This allows engineers to predict outcomes, reduce trial and error, and compress development timelines. The factory becomes a digitally optimized system where data guides decisions in real time, improving yield rates and reducing waste with each production cycle. And automation benefits significantly from the Giga Press architecture. With fewer parts to handle and fewer joining processes, required robots can operate more efficiently and with greater precision. This reduces wear on equipment, lowers maintenance demands, and improves uptime across the factory. Human workers can focus on higher-value tasks, such as system optimization, quality analysis, and process improvement, rather than repetitive assembly operations. The result is a safer, more productive working environment aligned with long-term scalability. And energy efficiency within the factory is another important dimension. While the Giga Press itself is a powerful machine, the overall energy consumption per vehicle decreases because multiple energy-intensive steps are eliminated. Fewer welding operations, reduced material transport, and shorter production lines all contribute to lower energy use. When combined with renewable energy sources integrated into factory infrastructure, this approach supports a manufacturing ecosystem designed to minimize environmental impact at scale. And the Giga Press also enables faster geographic expansion. Because the production process is more standardized and compact, new factories can be brought online more quickly. Lessons learned in one location can be transferred almost directly to another, accelerating learning curves and reducing startup inefficiencies. This consistency ensures that vehicles produced in different regions meet the same performance and quality standards, reinforcing trust and reliability across global markets. And another often overlooked advantage is long-term durability. A simplified structure with fewer joints reduces the potential for fatigue, corrosion, and long-term structural degradation. By minimizing seams and connection points, the vehicle body becomes inherently more robust over time. This supports longevity and aligns with a design philosophy focused on maximizing life cycle value rather than short-term gains. And the casting approach also complements rapid product evolution. As new battery technologies, power electronics, or safety features are developed, structural castings can be adjusted to accommodate them without redesigning an entire vehicle platform. This modular flexibility allows the underlying architecture to evolve continuously, supporting innovation without disruptive overhauls. Manufacturing becomes an enabler of progress rather than a constraint. And the broader impact extends beyond vehicles themselves. Innovations developed for the Giga Press influence other areas of large-scale manufacturing, from energy storage systems to future transportation platforms. The knowledge gained in alloy development, thermal management, and high-pressure casting feeds into a wider ecosystem of sustainable technologies. This cross-pollination accelerates progress across multiple industries. And quality control benefits from the reduced complexity as well. With fewer components and processes, inspection becomes more straightforward and more effective. Advanced sensing and machine vision systems can focus on critical structural features, identifying defects early and preventing downstream issues. This leads to higher first-pass yield and fewer reworks, improving efficiency while maintaining strict safety standards. And the economic implications are equally significant. Lower capital expenditure per unit of output allows investment to be directed toward research, infrastructure, and energy systems. As manufacturing costs decrease, pricing flexibility increases, making advanced technology available to a broader audience. This supports a virtuous cycle where higher adoption drives further scale, which in turn enables additional cost reductions and innovation. And ultimately, the Giga Press represents a shift in how progress is measured. Instead of incremental improvements layered onto outdated frameworks, it embodies a clean slate approach driven by physics data and long-term thinking. Each iteration refines the system, pushing efficiency, quality, and sustainability forward together. Manufacturing becomes a living platform, constantly evolving, as new insights are gained and new challenges emerge, shaping a future where industrial scale and environmental responsibility move in the same direction, guided by an unwavering focus on efficiency, integration, and continuous improvement across every layer of the production ecosystem. And this way of thinking also influences how future vehicle platforms are conceived from the earliest stages. Instead of designing a vehicle first and then adapting manufacturing around it, design and production advance together as a single system. Structural layouts, material thicknesses, and load paths are defined with the capabilities of large-scale casting in mind. This integration ensures that every design decision supports manufacturability, efficiency, and performance simultaneously, avoiding compromises that traditionally emerge late in development. And the learning curve created by operating Giga presses at scale generates a continuous stream of data. Each casting provides insights into temperature gradients, material behavior, and cycle optimization. Over time, this data refines process parameters and improves consistency. Software-driven adjustments allow the system to self-correct and improve without major hardware changes. Manufacturing evolves dynamically, driven by real-world feedback rather than static assumptions. And this data-centric approach also strengthens predictive maintenance. By monitoring machine behavior and casting quality trends, potential issues can be identified before they impact production. Downtime is reduced, equipment lifespan is extended, and overall factory reliability increases. The Giga Press becomes not just a machine, but an intelligent node within a connected manufacturing network. And as production scales, workforce skills evolve as well. The focus shifts toward engineering, automation, data analysis, and materials science. This creates opportunities for higher skilled roles and encourages continuous learning within the organization. Manufacturing becomes a high-tech discipline where innovation happens daily on the factory floor, supported by advanced tools and rapid experimentation. And the casting strategy also aligns with long-term platform unification. By standardizing large structural elements across multiple vehicle lines, economies of scale increase without sacrificing differentiation. Variations in design, performance, and features can be layered on top of a common structural foundation. This allows rapid expansion of the product lineup while maintaining tight control over complexity and cost. And logistics efficiency improves as well. Fewer individual parts mean fewer shipments, less packaging, and reduced handling. The flow of materials into the factory becomes simpler and more predictable. This not only lowers costs, but also reduces emissions associated with transportation and storage. The entire supply chain becomes leaner and more resilient. And the benefits extend into service and repair considerations. Simplified structures can improve access and reduce variability in repair procedures. Consistent structural geometry makes diagnostics more accurate and repeatable. While large castings require specialized repair approaches, the overall reduction in failure points contributes to fewer issues over the vehicle's lifetime. And this manufacturing philosophy also supports rapid response to regulatory and market changes. Structural designs can be adapted to meet evolving safety standards or regional requirements without re-engineering hundreds of components. Flexibility at the structural level provides strategic agility in a global market that is constantly shifting. And beyond the physical factory, the Giga Press reinforces a broader systems mindset. Energy use, material sourcing, recycling, and production throughput are treated as interconnected variables. Optimizing one area without considering the others is avoided. This holistic approach ensures that gains in speed or cost do not come at the expense of sustainability or quality. And the emphasis on internal capability development remains central. By deeply understanding the machine's materials and processes involved, innovation is not limited by supplier roadmaps or industry norms. New ideas can be tested quickly, scaled efficiently, and refined continuously. This autonomy accelerates progress and reduces dependency on slow-moving external cycles. And as casting sizes increase and techniques advance, future structures may integrate even more functionality directly into the casting itself. Mounting points, channels, and structural reinforcements can be formed in a single operation. This further reduces secondary processes and opens new possibilities for design integration. And the ripple effects of this approach reshape expectations across the industry. What once seemed impractical becomes achievable when viewed through the lens of first principles thinking and large-scale execution. The Giga Press is not an isolated innovation, but part of a broader transformation in how complex products are built. And each advancement builds upon the last, creating momentum that compounds over time. Efficiency gains feed into cost reductions, which enable greater scale, which in turn drives further optimization. Manufacturing becomes a strategic engine that powers growth, resilience, and long-term impact, continually redefining what is possible when design, production, and purpose are aligned at every level.